Yesterday I made a video about Magic Knights tours and I'm so glad to say they're getting the love they deserve, so here's another one to keep you mathematically satisfied. To recap, a Knight's tour uses the move a knight could make to go around and hit every point on a chessboard. This one's 16 by 16. And then, if you take all of the moves and number them, 1, 2, 3, following the route that the knight took, all the way up to 256, it forms a magic square. That's a square where all of the rows and all of the columns and all of the diagonals add up to the same number, in this case, 2056. Here is a side-by-side comparison of yesterday's Knights tour and today's Magic Knights tour, and you can see there are some similarities in their structures. So a great way to investigate this mathematically is to make things simpler. Here's an 8x8 chessboard, and instead of using the knight's move, we'll use a king's move so I can go to any of the adjacent squares. Let's start here where a king normally would be, and we'll place a 1 there. And since this is the smallest number, we want to pair it up with the largest number. And we're going to go in these alternating pairs up to 65 for all of the rows. So I put a 2 here. I need a 63 somewhere else in this row. And they're going to go along the row pairing off like this to create 4 pairs of 65, making the magic constant for this square 230. So we've got a start point and we've got an end point, and from here you might want to think about how you would make your way around the board, keeping the rows balanced with 4 pairs of a sum 65. If you want to do that yourself, then look away now because here come the spoilers. Okay, so one thing that comes up a lot in Magic Tours is this idea of braids, which is where you have a back and forth alternating of numbers that you can see here. And I'm just going to speed this along up to the halfway point, which if you think about it would make sense that it's over here opposite the 64, and that the middly numbers pair together the same as the extreme high and extreme low numbers pair together in the same rows. Follow the symmetry to get back round where we started, and we've got a magic tour with the constant 230. Let's have a look at what it would look like geometrically. You can see the braids forming, and then here it is, a Magic King's tour, which I hope can show you a little bit of the underlying structure to the more difficult Magic Knights tour, which cannot be done on an 8x8 board. You know, mathematicians, why make life harder than it needs to be when you could understand a simpler problem? Oh, and just as a fun wee blooper, here is my first attempt at this, where my second line was not the move that a knight makes at all. But I guess it's better to fudge it right at the start.